Hey folks, welcome to the NCEA Level 3 Maths and Stats probability paper from 2024. The way this video works is that I go through each question and let you know what you need to do for achieved merit and excellence. Now the best way to watch this video is to pause the video at the start of each question, try the question out by yourself, and then unpause the video just to see how I go about answering these questions. So without further ado, let's get started. Alright folks, so question one, of course they've got to have AI in it. What do we got? I guess we've got to kind of draw a probability tree. So the first thing I'm going to be doing for this question is I'm going to just draw a quick probability tree. So it says that a false positive is 1%. So let's say we've got something like this and we say they've used no AI. And here they have used AI, and from there we're going to get positive and negative, and with AI they're going to get positive and negative. So if you look at the first statement, and I'm looking at this statement here, 1% false positive, so that means this part here is 1% because it's said that they've not used AI, but the Turnitin is actually saying yes, they have used AI. So this branch here is going to be 1%. So that's going to be 0.01. So just highlight it this way so you guys can kind of see what's happening. And then 74% of the time it fails to detect AI generated writing. So that means that's going to be this particular branch here. That's going to be 0.74 because what it says is that 74% of the time it fails. That means AI was used. But 74% it didn't actually detect it at all. And the next bit of information that's quite useful for us is 22% of pieces contain that's content generated by AI. So this branch here is going to be 22% of students are going to be using AI. So at this point, we're just going to have to fill in the empty branches. So we've got 0.78 for no AI, 0.99, and we've got 0.26. So all those branches actually add up to 1. So once that's done, now we can actually answer question 1. It says if it's 120 pieces, approximately how many would be detected as being generated by AI? So for this question here, what we're looking for is how many would be generated by AI. So this is potentially generated. So we've basically got this branch here, and we've also got this branch here. Oh, sorry. Because those two branches there, it's pretty much adds up to the probability that it was actually generated by AI. So we've got 0.78 multiplied by 0.01 plus 0.22 times 0.26. So 0.78 times 0.01 plus 0.22 times 0.26. And that's going to give us 0.065. So I'm just going to put down here probability of indicated is equal to 0.065. So grades wise, we are looking at, I think this one is just what an achieved there, correct number of pieces of work. Oh, sorry. Yeah, I just realized I haven't actually answered the question, so I wouldn't get an achieved for this. The actual question is asking if 120 pieces, how many would be detected, not the probability. So I've actually got to go 120 multiplied by 0.065. And that gives me roughly 7.8. So we can say 8 pieces. Yeah, 8 pieces. And I think then I would definitely get an achieved. What a way to start the paper. Make a mistake straight away. Okay, cool. So that's your achieved question there. Let's go to part 2. Now part 2 says if a piece of writing is detected as potentially. All right, so what we're looking for in this question is we've got to find the probability concerned that a student could be unfairly accused of cheating. So we already have probability of AI indicated, which is above, that's 0.065. And the part where, I guess if you look at it, yeah, so they're unfairly accused of cheating. So if you look at that, that's going to be this particular branch here. Because on that particular branch, what's happening is that it's actually, they've not used AI, but it's actually come back to say that they have actually used AI. So it's a false positive, right? So what we're really looking for is probability that it was written by a human, and given that it was actually, and also like given that it was actually generated by AI. So when we look at this particular probability, what we have is, the way we write it is, we've got probability of human intersected with AI divided by probability that they actually did use AI. Now, if you look at human and AI, that is that first branch here, because this branch here is going to be that, human and AI. Yeah, it basically said it was human and AI. So we're going to have that as 0.78 multiplied by 0.01, and that's divided by probability that it was recognized as AI, which we found in the previous question. So that was 0.065. So that's going to give us a probability of 0.12. Now, what this 0.12 tells us is this: for pieces of work that is indicated as AI, 12% of these are produced by humans, and I think that's pretty much almost 1 in 8. So 1 in 8, because 12% is 1 in 8. So I reckon teachers should be concerned with the system that they have here, that a student is actually accused of cheating. Well, yeah, accused of plagiarism, if you want to use that word. Grades wise, we are looking at correct conditional probability is achieved. So that part right there is going to be worth an achieved. And correct conditional probability and comment. And a comment is going to be merit. Double checking everything. Yep, that's pretty much it for question 2. We now go to the next part of this question. All right, so let's actually write some of these probabilities down. So we're trying to figure out what they're independent of each other. So if we have probability of just cheating itself, that's probability of cheats is 0.01, so that's the first bullet point. The second bullet point is cheating, and then the second bullet point, sorry, I just realized that it was something else. The second bullet point is 20% complete the assessment in less than 25% of the allocated time. So that means if we look at it as less than 25% of the time, that's going to be 0.2. And then finally, 80% of students who cheat on the assessment complete. So this is time less than 25. And given that they cheat, is equal to 0.8. Now, if they are independent of each other, then P of A times P of B equals P of A intersect B. So what we're going to do is we're kind of going to figure this part out here. So we've been given, we want to first figure out what is the probability of time less than 25% intersected with the cheating part of it. Now that is equal to probability of probability of time less than 25%. Just bear with me on this, people. Given that they cheat, multiplied with probability of cheats. Now, if you're wondering how I got this, remember one of your conditional probability is P of A given B is probability of the intersection divided by that. So then the intersection is probability of A given B multiplied by probability of B. So that's all I've done here. So if we look at the actual probability, we've got 0.8 times 0.1, which is equal to 0.008. So now what we can do is we can actually do probability of cheats multiplied with probability of time less than 25%. That's going to be 0.01 times 0.2, and that's equal to 0.002. And here, what we can actually say is, because these two probabilities are not equal to each other, therefore these are not independent. So we can say probability of time less than 25% intersected with cheats is not actually equal to probability of cheats times probability of time less than 25. All right, because on one end you've actually got 0.008 is not equal to 0.002. Therefore, we can say that this is not independent. Now, the final part of this question, it says interpret your answer in relationship between that. So we can kind of say something like this. If students are cheating, we can say that it is more likely, about 4 times, for them to complete their assessment in less than 25 minutes. Not 25 minutes, 25%, sorry, of their allocated time compared to students who are not cheating. So grades wise, what do we got? Correct probabilities calculated for independence argument that could be achieved. So somewhere here could be achieved. Full and correct explanation that shows understanding of non-independence in context. So probably somewhere here for merit explanation, and this last explanation there is going to be worth an excellence grade. All right, moving on to the next question. What we have is estimate the proportion of students who cheat. So that's cheats and complete probability of cheats and complete the assessment for the standard in less than 25%. I think we already found this in the previous question as 0.008. So, and time less than 25%. Yeah, I think we have found this, because I mean we actually did this in the previous question right at the top there. So I would just write that as 0.008. And that's pretty much it, and you get an achieved for this question. All right, and then let's go to part 3. Give 2 reasons. There's a few reasons we can actually give here. The first reason is that I think this was just collected in one school. Yeah, I think it is actually done in one school, because I think it says in one teacher's course there. So if you look at it right here, that's one terrible highlighter, sorry. So we've got this one teacher's course that we're actually looking from. So because of that, first bullet point that we really can say is that data is actually collected from one school. And so if you have different schools, will pretty much give you different set of data. Yeah, so that'll change over schools, right? So that's just something to keep in mind. And I think it's a good idea to elaborate, guys. Sorry, I'm just going to write these as little bullet points for now. Data is also given only for this particular external assessment. So if you have like different external assessments, you're going to have different sets of data there as well. So data is only given for this particular assessment. We don't know what that is. And the last part that you can also mention is that not all cheating is actually detected. Some cheating can go undetected as well, because you really don't know when a person is cheating or not. So yeah, and I think if you can actually elaborate it a little bit more in detail and give that in context, then I think one reason is achieved without sufficient detail, and then if you go 1 with full detail, you get merit. 2 with a full detail, you actually end up getting an excellence. And I believe that's question 1 there, folks. All right, we got a question 2 now. All right, folks. So for the second question, what we've got a Venn diagram that we need to kind of work on. So I'm gonna create a big Venn diagram here, and I'm gonna put in, I think we've got like 3 little things that are happening here. Probably a bit too small. Let me try that again. Okay, so what I'm gonna do is I'm gonna create a big one there. So just to kind of get started there. So out of the 35, so this entire box is going to be 35. Out of the 35, 7 actually, if you have a look at it, 7 of them had none of the 3 skill sets. So skill sets we've got coding, which is going to be, I'm going to put that as a C there. Then we've got maths and stats. That's the maths and stats. And then we've got subject specific there with those 3 little circles there. Now it says 35 is total. 7 of them had none of it. So 7 is going to be outside. 21 had coding skills. So this is coding skills is going to be the yellow circle there. So that's going to be 21 applicants there. So I'm just going to put this 21 at the corner here. Then it says 16 had application, 16 had maths and stats. So that's this part here. This is actually worth 16. Then we've got 6 applicants that had neither specific subject understanding. So that means they are not neither, necessary. That's better. So that is going to be the blue one here. And so that's equal to 6 right there. All right. Now it says 9 applicants had exactly 2 of the main 3 skill sets. So if it's 9 exactly, basically what that means is that if you look at it, these parts here, this, and this, those 3 areas should add up to 9. Now it says 7 applicants were good candidates for the role except they didn't have any subject specific knowledge. So if it's going to be 7, so if 7 of them they didn't have any subject specific, that's going to be this little area here. So that's going to be 7 there because they don't actually have any subject specific language knowledge. The 1 applicant had only subject specific understanding. So 1 person had only subject specific. So that's going to be 1 there. Now also the very last one is out of those with 1, it's called 3/8 had mathematical and stats knowledge. All right, I was like stuck in this question for quite a bit of time, and I'm going to be honest with you folks. I was stuck in it for almost 2 weeks because I just couldn't figure out how to do this in my head, and it's because I haven't actually done probability in such a long time. But even now as I make it, I mean, if you had noticed the time, it's like almost 15 minutes. I'm just sitting there I thought I got it and then I didn't get it. But anyway, I'm going to show you folks how to do it. I think I finally got the hang of this. So this area here, and I'm going to kind of draw this in a pink line here. This pink area, we're going to actually work out what it is. And if you look at the pink, this area here, that's actually, let's go in the calculator. We've got, and I think you can see my working there. All right, let's try this again from the beginning. So what I'm looking at is the pink area here. That pink area is, if we add it up, we're going to get 21 plus 16 plus 6. That's 43, right? But if you actually look at it, the pink area is 43 minus the 7. So it's actually 36. So this area here is actually worth 36. So that's 36 people are inside that pink area. Now, we also know that this 3 parts here, they actually add up to 9, because that says 9 applicants have 2 of the 3 main skills. So this, and this adds up to 9. So what we're then going to do is we're going to do 36 minus 9. And when we get that, we actually get 27. So to give you an idea, it's this zone plus the middle plus this. These 4 zones equal to 27. So that's this one, this one, this one, and this one. They're all equal to 27. But what you have to understand is that the middle part is actually getting layered. It's getting added 3 times, right? So then what we can do is we can actually say we've got 27 is what we're supposed to have right now. But instead what we have is 36. I can see it in my head, but I just can't figure out how to explain it. Maybe I'll try zones then. Okay, let's try zones. So I've got zone A, zone B, zone C, and zone D. Now let's make it this way. So I know that when you look at all 3 of them actually should be equal to 36. But when we do, and then we've got E, F, G. So if we go 36 minus E plus F plus G, we actually end up getting 27. I'm such an idiot. Yep. This is why you gotta do these questions all the time. You know, I always make the stupid mistakes because I do this once a year, and then for a year I don't know what it is, and you know, after 2 weeks of struggling with this question, trying to figure out, and I just went through the question again and again, and I'm going, there's something missing. What am I missing? I just figured out what I'm missing. I'm missing the 35 part there. All right, so what that means is, let's actually go back and have a look at this. this little area here, this should equal 28. And I'm like, I'm sure I've done this method before. The reason that's actually 28 is because we've got to go 35, which is the number of applicants, minus the 7. So when we do 35 minus 7, we're going to get 28. So those three circles should add up to 28. But because we have 43 take away 28, because why do I go 43? 43 was because I took 21 plus 16 plus the 6. That gives me 43. Take away 28 is 15. If that's the case, the 15 that I've actually got here, so I'm doing 43, which is the three circles added up together, minus what it's supposed to be, which is 28, I actually end up with 15. So now the 15 here happens to be this part here. So that's the 15. But we do know that those three zones here, so zone A plus B plus C, A plus B plus C is actually 9 because that's also mentioned here. So we've got to go 15 take away 9, which is 6. And then because zone D is getting added twice, we've got to do 6 divided by 2, which would give us that particular zone, which happens to be 3. I'm so sorry I kind of like messed around with this. It's like 25 minutes, but you know, for you it'll be a little bit faster. But that's pretty much how you end up getting the 3. All right, now that I've done that part, I need to actually kind of work through the rest of it. This question is, I don't know why. It's just, I can't seem to explain it. All right, so what are we going to do next is that I now know that this red zone there, the red zone is actually not equal to 15. It's 12 because we've got this plus this is 9. So it's going to be 12. That means if I write a couple of letters, so I've got zone A, zone B, and I did say this was C, zone C. So what I should get is zone A plus zone B plus zone Z should equal to, we've got 28, which is, this is all 28. And then this part here is 12. So that zone A plus B plus C should equal to 16. Now, we don't know what zone A is. We do know what zone B is. That's actually 3 out of 8 of the 16. That's what it'll be. 16 is the total, so 3/8 of 16. Man, it's frustrating. So if the total is 16 and 3/8 of that is there, oh my God, it was right there. So 3/8 of 16 is equal to 6, which means zone B is equal to 6. Now I've got it after three weeks and half an hour of looking at this question. 6, 7, 3 makes 16, and because the green circle is 16, this will become 0. The red part there is I think it was 9 applicants did for 2, so it's going to be 7, 0, 2. And then finally I've got 7, 3, 2, that's equal to 12. 21 take away 12 is 9. I hated this question, and I think I just need to do more of these Venn diagram questions to get the hang of it. Otherwise I just spend so much time. All right, so let's look at the part 1 of this question. Short list of people with all 3 skills were created. Short list of people with all 3 skills were created. How many applicants were there for shortlist? Well, that's a nice and simple one because we've got the number there. That's going to be 3. That's worth an achieved. Then question 2 is calculate the proportion of applicants who had only 1 of the required skills. So only 1 is actually 16. So probability of 1 skill is 16 out of the 35. So that's going to be divided by 35. That's going to be 0.457. Why there is... And that's going to give me a grade of... All right, and it's going to give me a grade of achieved. But also, they say that 5 correct values in the Venn diagram and correct probability would actually get you a merit. So this is for the Venn diagram that you will get some marks for it as well. So if you get all the numbers correct in there, you're actually looking at getting a merit. Part 3 looks like a risk question, so we've got to try and work out the probabilities. So the first probability that we're going to need is probability required mathematical skills applicants twice likely to subjects compared to coding skills. So we're going to look at probability of coding given that they do maths. And then we've got to figure out probability of subject specific given that they're maths as well. So we're going to look at this probability here, which is probability of coding and maths over probability of maths. And on this side, we've got probability of subject specific and maths given that they are maths. So I'm going to work out the probability of maths first, mathematical skills first. That's 16 there. I think we already have that. So that's going to be 16. And then we're going to look for C and M. If you look at C and M is this part right here. So that's going to be 10. Subject specific and M is going to be this one here. That's going to be 3. All right, folks. And now if we look at the probabilities itself, I'm just going to work out the probabilities very quickly. Where is it? We've got 10 over 16. That's going to give me 0.625. Then we've got 3 over 16, and that's going to give me 0.1875. So at this point, what I can do is I could actually do coding over the subject specific. And if you look at it, we've got 0.625 divided by 0.1875. See, there's a little flare going. I don't know why. 625 divided by 0.1875. So that's going to give me 3.33 times as likely. So we're just going to have to write a little statement here. And the statement is, it is over 3 times likely to see coding than subject specific for those guys with maths and stats. For those with maths and stats. Sorry, I'm just writing it as code, but I'm hoping that you guys would be writing it in full sentences. All right, so grades wise, one probability calculated would get you an achieved. Both probabilities calculated and relative risk is going to give you a merit. And then explanation will get you an E for this question. All right, let's go through the next one. I did not like that question at all. Glad to get over that question. I think it's because I haven't actually had practice in those. That's why I spent so long with that. All right, team. So for this question here, based on the data, we've got total proportion of 18-year-olds has increased between 2012 and 2022. Correct. Is it correct? All right. So firstly, we're going to look at the total number of people that was in 2012. Now, total number in 2012 is equal to 77.3. And then in 2022, we've got 82.4. Then you can kind of say, that it does make sense because 82.4 is actually higher than 77.3. So you can say one thing is like, yep, that could actually kind of work out. But then in 2018, we've actually got 85.1. So you could also say that it's actually not consistent because it actually peaked at 2018. So you could actually mention that. What else can we do? Well, yeah, based on that, you can actually say that there's actually kind of no consistencies. It's kind of like going up and down anyway. So that's all you can pretty much say with this. I would write this as a statement, folks, more than anything else. So I would write that 77.3 and 82.4. And I'll also mention the peak. And I think looking at the grades, you could do that, or you could also do it with comparing the two probabilities. So you could actually look at 82.4 divided by 77.3. That's going to give you 1.066. So that's like a 6.6% chance more likely to have NCEA Level 1 in 2022 versus 2012. So you could do a risk there as well if you want to explain it. So you could go 82.4 divided by 77.3, which is 1.066. So that gives you a 6.66% chance, or 6.66 more likely, not chance, to have NCEA Level 2 in 2022 versus 2012. That's something you could do as well. So pretty much a little statement describing these two probabilities will get you an achieved. mentioning the peak would get you a merit, or additional calculation and additional calculation. So yeah, you could actually get a merit for doing the relative risk as well. So it's another thing you could actually do. As for the next one, we've got comment on the contribution, total proportion between 2012. Okay, so there's a lot of things that we can potentially do here. So level 2 and 2012 or above. Now we already have the first bits of data there, right? So we've actually got probability, well, not probability, proportion. The proportion is actually what is it looking at? Post-school qualifications. Okay, so I got to go back. So post-school, that's the red one. So 6.1 out of this 77.3 is post-school. So it's going to be 6.1 out of 77.3. And then in 2022, we've got 4.1 out of 82.4. So what I could do is I could actually look at the relative risk for this. So when I do 6.1 out of 77.3, calculator, 6.1 out of 77.3, I actually get 0.0789. Then I'm going to do 4.1 out of 82.4, and that's going to give me 0.0496. So from here, if I actually work out the relative risk here, so we've got 0.0496 divided by 0.0789. So 0.0789. That's going to give me, it's actually 0.6306. Now, what, I'm just looking at the two proportions, right? And you can kind of see that it's now 0.63, which means it's actually reduced by 37%. There's a 37% decrease to it. And how I figured out that 37 is that 1 minus 0.63 is equal to 0.37. So you can kind of say that there is a 37% decrease from 2012 to 2022 for proportion gaining post-school qualifications. So in other words, you can basically say that the 18-year-olds are much less likely to gain their NCEA Level 2 post-school in 2022 compared to 2012. And I think a statement would, I think you might have to write a statement like that at the end. Yeah, you do need, actually no, comment using relative proportion. You don't need to, but because actually it says comment, we probably would say that. So we can actually say 18-year-olds are much less likely to gain level 2 post-school in 2022 compared to 2012. Grades wise, we're looking at least one correction proportion calculated is going to be achieved. So one of these two things is going to be achieved. Relative risk gives you a merit, or both proportions. So if you get both of these values, you actually get a merit. Wow, that's pretty generous. And then excellence is for the final part. I am not going to lie. I hated this question. I cannot believe I was stuck on it for such a long time. I guess sometimes it's like, sometimes I'm able to see the answers and I'm able to explain it, but sometimes it's just, I'm like, what's happening? And today was one of those moments. I was hoping to finish recording by 6:30, but yeah, let's just keep going. It's question 2 done, folks. That's question 2. Yeah. All right, so getting through question 3, we've got player plays 2 different games, A and B. For game A, if the total of the 2 dice is 5 and 10 inclusive, then the player wins. Calculate the probability of winning at least 3 times. Well, okay. So winning on 1 occasion, so that's actually probability of 5. Going to do a quick little table here just to kind of get things rolling. So 4, 5, 6. Now probability of 5 is going to be 4 and 1, 3 and 2, 2 and 3, 4 and 1. Probability of 10 is going to be 6 and 4, 5 and 5, and 6 and 4. And I just read the question wrong. It's actually inclusive. So if it's inclusive, then we're also going to include all of these things here. And if we look at it, it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So probability of winning, so that's probability between 5 to 10 inclusive, is going to be 27 out of 36. And we want to find out what's the probability that a player wins at least once when playing 3 times. So that means we could, you can kind of do it like this. So you've got 27 out of 36 is win. 27 out of 36 is actually, should just write this as 3 over 4. Yeah, 3 over 4. And if it's 3 over 4, 1 over 4 is loss. Loss is 1 over 4. Loss is 1 over 4. So what we could do is we could actually figure out the probability that they lose 3 times. And then if you go 1 minus that, you're going to get probability of winning at least once. So probability of losing is 1/4 to the power of 3. So then probability of winning at least 1 is 1 minus 1 over 4 to the power of 3. And whatever that is. So we've got 1 minus 0.25 to the power of 3, not 4. And so that's going to give us 0.98. 4375. Looking at grades, correct probability of winning 1 game is achieved. I guess that's achieved there. And then final probability is merit. All right, firing through these questions. Next one. Okay, I'm going to try and draw this as a tree diagram, but I'm also going to use the previous table there. So when a player rolls the first time, any combination of 2 dice that adds up to 7 is a winner. So to get a winner, that's going to be 6 out of 36, because 6 numbers, there's 6 combinations of 7. Then any total that equals 2, 3, 11, or 12 is an immediate loser. So 2, 3, 11, or 12. So 2, 3, 11, or 12. Okay, so that's going to be 6 as well. Yep. And then we've got, if the first roll has not produced a winner or a loser, the total of the dice becomes known as a point. So to get a point, that's going to be 24 out of 36. All right, for all successive rolls, the player will win a game if a point is rolled again. However, if a 7 is rolled before the point is rolled, the player loses. What? I could be completely wrong in understanding this, but I feel like from here, for all successive rolls, the player will win a game. So if they'll win a game, if a point is rolled again, so that's going to be 24 out of 36. However, if a 7 is rolled before the point is rolled, the player loses. So that's going to be 12 out of 36. Because they also lose if they get... No, hang on. I think this is what it is. For all successive rolls, the player will win a game if the point is rolled again. However, if a 7 is rolled before the point is rolled, the player loses. But then they say on the first roll. So it's only on the first roll. So I guess there's only 6 chances. I wonder what happens if they roll a 2, 3, 11, or a 12 for the second roll. It doesn't really say. Okay, let's just look at this. Now the probability, what are we finding out? Probability of the game is lost before the player has to roll for a dice for a 3rd time. Well, that's thankfully, we just got to add this branch and this branch together. So probability of loss before 3rd roll is equal to 6 out of 36 plus 24 out of 36 times 6 out of 36. So working that out, we've got 1 over 6 multiplied by 2 over 3. No, not multiplied, plus 2 over 3 multiplied by 1 over 6. And that gives us 5 over 18 or 0.277. Yeah, 5 over 18. That's the probability. So grades-wise, correct probability for losing in either first or second roll, it'll get you an achieved. And probability of losing before the 3rd roll gets you a merit. All right, next question. Sorry, there is a table there, but it's just disappeared. So what I'm going to do is I'm going to look at probability of rolling a 3, which is actually, or 3 or less, sorry. So 3 or less. Probability 3 or less. There is a glitch happening. I thought I saw it. Must be my cable. I need to have a look at that later. Probability of 3 or less is, we're looking at these 3 numbers here for probability of 3 or less. And so what we're going to get is 138 plus 189 plus 197, and that's equal to 524 out of 1000, which is 0.524. Then I've got to look at probability of 4 or more. So 4 or more is going to be the other side, but I already know what that is because that's just 1000 minus 524, so that's going to be 476 out of 1000, which is equal to 0.476. And from here I can say that a probability of 3 or less is more likely. Grades wise, correct explanation gets you an achieved. Right, so the question here is, should the player be concerned that one of their dice is biased? Use the results. They're actually saying refer to experimental, theoretical, and true probability as part of your answer. Now, first thing is that when we look at the probability, we know that this is all equal to 1 over 6, 1 over 6, 1 over 6, and 1 over 6. Right, that's what we should be getting at. So unfortunately, I'm just going to talk you folks through this rather than kind of write this up, but you're more than welcome to have a look at the answer schedule on NZQA's website, and you can have a read through a bit more. But basically, you know, the true probability, it's actually unknown, right? Because we don't know what it's going to be. But what the experimental probability is actually, or theoretical probability, is actually 1/6. Now, when we actually compare these probabilities, you know, one is supposed to have like a 1 out of 6 probability. But what's happening in this particular case, I think in this case it was 0.138. And the reason we got that 138 was from the previous question. They've actually given all the outcomes for us. So one actually had that's the observed probability. And then even if you have a look at the simulated results, right, like, I mean, you've actually got a lot less ones. And so because of that, I would actually say that, yeah, the player should be concerned that the die is actually going to be biased. So grades wise, looking at experimental probability, it's actually different from the theoretical probability. That's going to be for achieved. A discussion of how simulation. Yeah, so the simulation above, you can kind of have a look at it versus what we actually got in the previous one, which is the 138. Again, just talking about what you expected versus what you actually saw. They do mention about sampling variability. I mean, we've got a fairly large sample size, but also one thing that you have to remember is that whenever it comes to these kind of dice, the higher your sample size is, the more likely you're going to get closer to that. Not to the real probability, but you get closer to it. I know I'm probably doing a terrible job of explaining this, and that's one of the reasons I don't actually do much of this. I like the calculations part of it, but the explaining part of it, I am absolutely horrible at. But yeah, so if I didn't make any sense, go and have a look at the answer schedule. I'll see if I can someone drop a comment and I'll put a link there. So achieve merit excellence, the 3 parts, it just depends on all of it as how you actually explain it. Now the last part of the question says what this results means for a chance of throwing a total of 2 using this particular dice. So I think in this one, you're actually looking at on the pair of dice in game B. So because if you remember, like in the game B, I think, which was, where was it? It was this one here. In game B, if the dice actually equals to 2, you become an immediate loser. And in this particular case, if the dice is actually biased, then fewer ones are coming, which means the probability of getting a 2 is going to be reduced. Because, you know, you've got to get 2 ones to get a total of 2. That means it's also less likely that you're going to roll a 2 and lose the game. So again, interestingly enough, they've actually given an E grade for that one as well. An E8, which was, yeah, interesting. But yeah, sorry folks, I didn't actually write the explanation and I kind of just talked through it. But that's pretty much it for this paper. Now, excellence, they were very kind in excellence for this exam paper. They were actually giving 19 for an excellence, which is actually very kind. Like 19 is always a kind score. And for merit, you only need 13 points to get a merit. Yeah, I think I got stuck in that question too a little bit longer than expected. So yeah, and I think that's partly my fault because I don't actually do much of statistics, and I do 1 paper a year and then end up getting stuck for a long time. Anyway folks, look, that's basically it for this paper here. Yeah, with your exams, make sure you attempt all the questions. And what can I say? Good morning, 6:43. Time to get to work.
Hey guys, that is basically it for this video. As always, don't forget to like this video, share this video, and of course subscribe to keep up with the latest content. There should be some playlists popping up. Check them out. Great revision material. And as always, thank you for watching.